Hey there, in this section we're going to talk about measures of variability. So this concept basically deals with descriptive statistics and it gives us more information about our data. So the whole concept revolves around the dispersion of our dataset and it gives us the location of our data. Which may sound a little weird that location has no relation with the data, but let me assure you that the information that we're going to get and the range of values which our data tells us a lot about our distribution, our dispersion, and it's going to help us in different ways, in many ways, and it's going to provide us with more information. So the term basically tells us that we are measuring the variables in different ways. So there are different tools and concepts, and we're going to study all of them to give us a better understanding of our dataset. So as we're talking about describing our dataset, so this is a branch of descriptive statistics, and we're going to further extend the concept by learning new things, by learning new methods, and we're going to apply them to describe a dataset in a much better way. So the first thing, before we learn anything, I need to tell you about outliers, because this is going to be repetitive in the whole section, and we have also seen this concept when we were studying box plots. So you have a somewhat idea what outliers actually are and how we can identify them when we are visualizing a dataset. So as you can see that any extreme value in the dataset, whether it be extremely small or extremely large, we call it an outlier. Let's take this example. It's a score of 5 students, and we need to identify which one of them is an outlier. It's pretty obvious, and you can see that there's only one value that is not related and somehow is different from the all other values, and that value is 55. Yeah. So whenever we're talking about outliers, we need to understand two basic rules whenever you study them. Obviously, this is a small dataset. You can tell them by only looking the values. But if we have thousands or hundreds of values, it would be difficult for you to determine which of them is an outlier or how many outliers there are. And these outliers greatly make a difference whenever you're studying the dispersion and the location of your dataset. So it's important to understand them and to locate them and to point them out. We have seen certain techniques like box plots which are used to identify them. So whenever we're talking about the location or the dispersion of our dataset, we need to understand the central tendency. How much the data is whether centrally localized or whether it's spread out. For that purpose, we need to understand the 3 M's. The 3 M's are the mean, the median, and the mode. These are the most commonly used in basic statistical concepts. I hope you've studied them in high school or somewhere else. It's the most commonly used, and most of the people already know the basic concepts, even though we're going to go through them one by one, and we're going to understand their importance, and we're going to learn how we can use them in describing our data more. So let's talk about mean. Mean is taking the average of the dataset. We're going to sum all the values and we're going to divide it by the total number of values. Don't get confused by the summation or these notations. They just mean that we're summing the values. And the X bar notates just another, you can say, representation of taking mean. So it's a statistical notation, a mathematical notation. It's a language, you can say this is just a grammar. Whenever we are writing algorithms, whenever we are writing our concepts down, we need to understand the vocabulary and the language we use for representing formulas. So that's just it. Basically, we're just summing the data and we're dividing it by the total number of values, and it gives us the mean or the average of the data. The one thing we need to understand about mean is it is greatly affected by the outliers. So we can't just depend on mean to tell us everything about our data. That's why we have median and mode. So the drawback of using mean is that it's greatly affected by outliers. So what if your data has a large number of outliers? So mean would be ineffective and it would completely be disarmed by those outliers. So we need a different approach. We need another method. For that, median comes for the rescue, and it tells us the middle value of a sorted data set. So this is the formula, and over here we're talking about n is the size of the ordered data set. So there are 2 rules to follow whenever we are using the formula, but before we go into that, n is the size of the ordered data set. So it's pretty obvious from this rule. We can say that the first characteristic or the rule to apply median is that we need to have a sorted data set, or we need to sort it. So that is additional operation we need for applying median, and sometimes it becomes quite difficult to do that in terms of computational complexity whenever we are doing that in algorithms or any other way. So whenever we apply the median formula, there are two rules to follow. So the first rule is that if n is an odd number, then median is represented by the numerical value corresponding to the positioning point of the observed observations. Let's imagine, although we're going to study an example, but the important thing is to remember that what the answer you get whenever n is an odd number and you put that n in the formula, and the answer you get points us directly to the location points directly to the value that is the median in the dataset. The second rule is obvious, that whenever n is an even number, that would be, we would have to understand that then the position where n tells us the median lies is between the two observations in the middle of the dataset. So I hope this might not be clear at the moment, but we're going to go through an example to give you a better sense. For now, just remember that if n is an odd number, it's quite easy. We just put that n in the formula, and the value it gives us, it's the location of the median value in the dataset. And if it n is an odd number, it points us to two values, and we have to select the middle one out of the two values. So median performs well in the presence of outliers. So this is something we can use to combat outliers. So this is an example, and let's go through this one by one. Example on the left hand side, let's go through this. This is the exact set of scores we saw earlier, and these are the set of scores of those students. And the first thing we do is we identify the outlier, and that is 55, and then we count the dataset size, and that is 5, which is an odd number. Now 5 is an odd number, so we calculate mean. It's pretty simple. We sum all the values, we divide it by the total number of values, and 83.2 is the mean we get. Median is, we put that 5 into the formula. 5 plus 1, 6. 6 divided by 2, 3. So the 3 is the number, and since the data set is sorted, we're going to count from left to right. 1, 2, 3. Bingo. 89 is the median for this data set, and 3 is the value we got from the formula, and that is the location, or you can say index, which tells us where the median value actually is. I repeat, it's not the median itself. The formula does not provide us with the median, rather it only tells us where the median is in the dataset. So mode, we haven't studied it, so let's not talk about it for now. And by chance, we don't have any mode concept in the dataset either. So let's talk about a dataset where we have, let's remove the outlier. So the reason for that is, actually I want you to understand the concept of median, where we have an even number of even size dataset. So when we remove 5 after removing the outlier, the mean obviously changes, but the median, let's see. Now let's count 4. Let's put that value in the formula. 4 plus 1 divided by 2, that is 3.5. So that is somewhat difficult when we saying that. So let's count that 0, 1, 2, 3. So the value is somewhat between, you can say 4 plus 1, 5 divided by 2, 2.5. So 1, 2, and 3, somewhere between 2 and 3. So what we're going to do is, we're going to take the two values, the 2 and 3, and we're going to sum them and divide it by 2. So 89.5 is the middle value between 89 and 90. And that would be the median. So remember, whenever you have an even number size dataset, we're going to put it in the formula, and you will probably get a fractional number, and the fractional number would be between two other numbers, like 2.5 is between 2 and 3, and we pick those values, the second and the third value, and we sum them and divide it by 2. In the end, we get the median. Let's talk about mode. Mode is also referred to as the frequency of the dataset. We're going to count the number of values, the exact number of each value it occurs in the dataset. Let's take this example. So the number of 3's is 2, the number of 16's is 3, and the number of 27 is 2. So the mode is 16. Why is that? Why is the mode 16? As you can say, it is the most common value in the dataset. 16 has the maximum count, which is 3, so that would be the mode for this data set. Remember, it's not the count, it's actually the value that is repetitive, and the same concept applies to median. It's not the position itself, but the value where the position lies. So the count itself, the value of the maximum count, is the mode. It's simple as that. It's also immune to outliers, so we can also use this for getting a better understanding of our data. So what we learned till now is that we got a sense of our mean, the average, we got a sense of the middle value, and we got a sense that which value is the most repetitive in the data set. Now, there is a certain condition we need to understand in mode. Let's say that we have two values that have the exact same count. 3 and 16, they're both 3 times repetitive. So what then? How do we decide which one would be the mode? The thing is that a data set can have 2 or more modes. We can call it bimodal, trimodal, or multimodal. And a data set can also have no mode. So if you can remember, in histograms, we studied a concept called bimodal, and in that, there were 2 peaks in the histogram, which represented that there were 2 values which had the maximum frequency. And this is you can say, the concept which we apply, mode. It tells us that the 2 values would be the bimodal reference, and they would tell us that there are 2 values in the dataset that have the same maximum count. So let's revise the concepts we have studied. Mean is a good measure for dataset without outliers. Median is more accurately described data with outliers. Mode is good measure to use when we have categorical data. So this is important to understand. You cannot use mean with the dataset that is bombarded with outliers. Too many outliers, mean is going to fail. Median is more accurately described data with outliers. So when you have outliers, median is your best choice. Mode is basically used against categorical data. And it's pretty easy to understand that even though you can say categorical data is the one that can be the characteristic that can efficiently describe categorical data is its frequency. So for that purpose, mode is our best choice to describe categorical data.